Hello guys, nice meeting you once again. So in today's video, we are going to learn about the Nyquist and then the Shannon capacity. So here we are going to look at data rate limits, bandwidth, and signal levels. Now, in networking, whenever you are transmitting data across a media, there are so many factors that affect this data. So some of these factors are: one, noise. Noise is simply unwanted signal that interferes with the original signal. Now, noise, we have so many examples of noise, like the thermal noise, the crosstalk noise, and so on. And then we also have attenuation. Yes, so whenever I talk about attenuation, it's simply the loss of signal strength, and normally it is measured in decibel. Good. So what do we need to know about this? Now, in attenuation, right? When we are looking at digital signals, the only way we can boost analog signals is the use of amplifiers. And whenever we are dealing with digital signals, they are repeaters. Okay, so we have this question, right? So suppose the spectrum of a channel is between 3 megahertz and 4 megahertz. SNRdB is 24 decibel. So these are the parameters that we are going to look at: the 3 megahertz, the 4 megahertz, and then the SNRdB. So the first question: what is the Shannon capacity? Then the B, data rate of the medium. The C, how many signaling levels are required? And then the D, how many bits can be encoded at a time? So first of all, we need to understand the parameters given. Now we talk about what we call bandwidth. Now, bandwidth is simply the maximum number of data transfer across a network. So the bandwidth is the difference between the upper limit and then the lower limit, which is the 4 and then the 3. So we find the difference that gives us our bandwidth. So in this video, we can use B as bandwidth, but let's just use W as bandwidth to make it look nice. Right, so write our formula. The bandwidth, which is W, is equal to the upper limit, which is 4 megahertz, minus the lower limit, which is 3 megahertz. Now, in prefixes, when we talk about mega, it's 10 to the power 6. Yes, so the difference is going to give us 1 megahertz, which is equivalent to 1 times 10 to the power 6 hertz. So the unit for hertz is frequency. Yes, the hertz is the unit for frequency. So now SNRdB is equal to 10 log 10 SNR, where the SNR is the signal to noise ratio. Now, the signal to noise ratio here, the SNRdB was given. So this is the convention that we use. The SNRdB is 10 log 10 SNR, and we are going to make the SNR the subject here. So we need to divide through by the 10. So the SNRdB was given, which is 24. So 24 is equal to 10 log 10 SNR NR. So we are looking for SNR. What do? Let's divide through first by the 10. So we are going to divide through this equation by 10. But first off, let's move to the next page, or let's get this done on the next page so we can complete it. Okay, so let's just rewrite them. So 24, which is the SNRdB, 24 is equal to 10 log 10 SNR. Alright, so let's divide through by the 10. So divide through by 10. So when we do that, 24 over 10 gives us 2.4. It moves only one decimal place to the left. So 2.4 is equal to log 10 or log base 10 SNR. And we are interested in finding the SNR, which is the signal to noise ratio. So what do we do here? we deal with what we call the anti-log or the anti-log, as they call it. We deal with what. So this is very simple with a calculator. So the anti-log is going to give us shift plus log. That will give you 10 to the power. Then we bring the 2.4 there. So the anti-log is 10 to the power 2.4. So we have our SNR. Now we've made the SNR the subject here. So what do we do next? Now we have the value for the SNR. So the anti-log of 2.4 is 251.19. So the unit is dB, which is the decibel. Alright, so now we've been able to find our signal to noise ratio, and we have our answer to be 251.19 dB. Okay, so what do we do next? We need to find the Shannon capacity, where the Shannon capacity is equal to our bandwidth times log base 2 into bracket 1 plus SNR. So this is the reason why we found the SNR in the first place. So the SNR is the signal to noise ratio. So now let's go ahead and find for the Shannon capacity. So for A, Shannon capacity is equal to our bandwidth, which is the W, times log to the base 2 1 plus SNR. Alright, so let's evaluate this, or let's substitute the values into it and then complete it. Now the Shannon capacity is going to give us the bandwidth, which we found was 1 megahertz. So the bandwidth was 1 megahertz. As you can see from there, it's 1 megahertz. So our W, which is the bandwidth, is 1 megahertz times log to the base 2 to brackets 1 plus our SNR. So what did we get for the SNR, which is the signal to noise ratio? We had 251.19 decibel. Alright, so let's substitute this value into it. So 251.19. Alright, so let's evaluate this. So in the first place, we know that mega is 10 to the power 6. Alright, so in doing that, we are going to expand this. So we have 1 times 10 to the power 6. So it is very important to know your prefixes, because sometimes questions may be given for you to decode it. And then so we have the kilo and so on. So 10 to the power 3, the 10 to the power negative 3, and so on. So here mega is 10 to the power 6. So we have 1 times 10 to the power 6 multiplied by our log to the base 2 to bracket the sum of 1 and then 251.19 gives 252.19. Alright, now when we find the product of this, when we find the product of these two, which is the 1 times 10 to the power 6 multiplied by the log 2 of 252.19, we are going to get a huge figure. Yes, a huge figure. So we are going to get something like 7978367.26. So this is what we're going to get. So which is should I say, can be a bit confusing. Yes, so to be on the safer side, let's make everything simple here. Forget about the 1 times 10 to the power 6. We know 1 times 10 to the power 6 is mega, right? So let's forget about the mega and focus on the log base 2 of the 252.19. So let's focus on this yes, to make our answer very simple and brief. All right, so log to the base 2 of 252.19 gives us 7.978. Yes, so now as you can see, we have it to be simple. So this multiplies the 1, so it becomes 7.978 megabits per second. So we have 7.978 megabits per second. Yes, so this is our Shannon capacity. So this is the answer that we are expected to have. So let's round this up. So we have 7.98 megabits per second. Okay, so this is supposed to be our answer after rounding. So we have that. So now we have the Shannon capacity. We've been able to evaluate the A. So what do we do next? The next thing that we do is the B, and then they're asking us to find what the data rate. So the data rate, let's just use the rate is equal to so the data rate is simply same as the Shannon capacity, so there's no need for you to solve anything here. Now when we talk about data rate, it is the rate at which data is being transmitted across a media. So the data rate here is same as the Shannon capacity. So the unit for the rate is megabits per second, which is same as the Shannon capacity. So our final answer here is same as what we had for A. Let's focus on the C. So how many signaling levels are required? So they are asking us how many signal levels do we need for this data to be transmitted. So this signaling level is just like the Nyquist, right? So the Nyquist deals with noiseless channels, and then the Shannon deals with the noisy channel. So the formula C is equal to 2 times W multiplied by log to the base 2L, where the C is the Shannon capacity. Alright, so now we are going to find our L, where the L is the signal level. Alright, so now we have the Shannon capacity, we have our data, we have our bandwidth. So let's just substitute these values and then evaluate the answer for the L, which is the signaling level. Okay, so our Shannon capacity, which was 7.98 megabits per second. So let's just focus on the value. So we have 2 multiplied by our bandwidth, which was 1 megahertz. 1 megahertz multiplied by log to the base 2 of L. Log to the base 2 of L should be equal to the Shannon capacity, which was 7.98 megabits per second. So we have 7.98 Alright, so what do we do next? Since we are making L the subject, what we do first is we divide through by the 2, right? And then the 1 megahertz. So we have mega and mega, so simply they cancel out. So it becomes 7.98 divided by 2. So 7.98 divided by 2 times 1 megahertz. So as I said, the mega cancels out. So simply we have something like 7.98 over 2. So we are finding half of 7.98, which is supposed to give us let me punch this. So we have log 2 of L to be equal to 7.98 over 2. That gives us that gives us 3.99. So let's forget about the units and focus on the numbers. So this gives us log 2 of L is equal to 3.99. 3.99. So the actual answer that we're going to get is 3.989, right? But when we round it to the nearest decimal place, we are going to get 3.99. Okay, so what do we do next? We have log to the base 2 and we want to make L the subject. So this means that we need to find the anti-log of both sides. Yes, so we find the anti-log or the anti-logarithm. Let me put it that way. Yes, probably you are not familiar with the anti-log, so anti-logarithm. Okay, so what this anti-logarithm means is that wherever there is log, it goes to 1. Yes, so when you put this in the calculator, you are going to get 2 to the power 3.99. The anti-log of 3.99 is 2 to the power 3.99. So this is going to give us 15.89 15.89. So let's round this up. We're going to get 16. In the nearest whole number, we're going to get 16 levels. So these are the number of signaling levels that we need. So we need 16 levels. So this is supposed to be our C. So the C, which is how many signaling levels are required. So this is simply the Nyquist. Yes, the Nyquist. Let's focus on the D, which is the data rate of the D was let's go back and refer. The D was how many bits can be encoded at a time. So we have encoding and then decoding. It's similar to multiplexing and then demultiplexing. Yes, so we encode and then we decode. Alright, so are bits encoded, or a number of bits encoded is equal to log to the base 2 of L. Just that. So log to the base 2 of L, where the L is the signaling levels. We just found the answer, which was rounded to give us 16 levels. So without wasting much time, let's fix this in it. So we have 16. Good. So log to the base 2 of 16, we know from the properties of the logarithm, when you have log to the base 10, you get 1. When you have log to the base 2, you get 1. Now 16 is simply 2 to the power 4, I guess. Yes, 2 to the power 4. So now from the properties of logarithm, when you have log to the base 2, you are going to get 1. So simply you're going to get something like 1 times 4, which is the power. Now the power drops, right? The power drops. So we have log to the base 2, which is 1. So the power, which is 4, drops. So we're going to have something like 1 times 4, which is same as 4. Doesn't change. 1 is an identity element. Yes, so we have 4. So our final answer is 4. So for what? They're asking us the number of bits that can be encoded. So simply we have 4 bits. So this tells us that we can encode 4 bits with the 16 levels. Yes, so therefore 4 bits can be encoded at a time. Yes, so this brings us to the end of the problem that we had. So let's write a summary of what we had. So for the A, we were supposed to find the Shannon channel capacity, and then the answer we had was 7.98 megabits per second. So let's write that 7.98 megabits per second. So this means that 7.98 megabits are transmitted, transmitted every second. Alright, now the second part, which was the B, what were we supposed to find? Let's go back and refer. So the B was the data rate. So the data rate, as the name implies, rate. So it's the rate at which the data is being transmitted, which is same as the Shannon capacity. So the answer doesn't change. We have 7.98 megabits per second. And then the C, they asked us how many levels or how many signal levels. So we had 16 levels. And then the D, which is the last part, we were supposed to find the number of bits that can be encoded at a time. So we had 4 bits. Yes, so this brings us to the end of our problem. So these are the answers that you're supposed to get. So if you have any question, feel free to put that in the comment section. Hit that subscribe button so you stay updated whenever a new video is dropped. Have a nice day.